Welcome to this training about Infineon's offering for automotive electrical power distribution. Modern cars provide an increasing number of applications to improve not only our comfort but also our safety. The power distribution system supplies all these applications and enables the secure and controlled energy flow from a source, for example the battery, to all kinds of loads in the vehicle. The classic physical solution for the power distribution system is composed of a wire harness to transport energy, relays to open and close the energy flow, and fuses to protect the wire harness. Infineon provides a wide range of products for this increasingly important vehicle component. Come along and find out more. By the end of this training, you will be able to indicate what an electrical power distribution center is. Explain why relays and fuses are being replaced with semiconductors. Identify the devices that Infineon provides for replacing relays and fuses, and describe what solutions Infineon offers for electrical power distribution centers. Let's start by understanding what an electrical power distribution center is. Modern cars have more and more advanced driver assistance systems. This means that safety-critical applications need to have high availability. Even more challenging is the implementation of the so-called automated driving functions, which introduce fail operational requirements to the incorporated systems. The overall resulting requirement is then called dependable power, which is the failure-tolerant supply and distribution of energy within the vehicle. This needs to respect functional safety aspects with reliable technologies and trust in safety development. Moreover, this dependable power has significant impact on the power distribution architecture and related components. Hence, replacing relays and fuses with semiconductors allows implementing diagnostic functions not only to improve protection but also to increase system reliability. Let's now discover why relays and fuses are being replaced with semiconductors. Relays and fuses are being replaced with semiconductors because semiconductors enable diagnostic functions, offering precise current sensing and fast overcurrent protection. In case of a short circuit, semiconductors disconnect in less than 100 microseconds for wire protection and fast isolation. A fuse takes several hundreds of milliseconds. This may be fast enough to protect the wire, but it is too slow to avoid a power net damage. Second, after a protective switch-off, semiconductors indicate the type of failure and are resettable by the microcontroller. Fuses, in such a case, simply blow up without any notification. Last but not least, semiconductors increase system reliability by enabling a much higher number of switching cycles compared to a relay. But that's not all. They also enable PWM operation and provide diagnostic feedback for load current, open load, and short circuit, and offer higher current density in smaller footprints and reduce power losses up to a factor of 7. You can find much more information on Infineon Internet pages. Now that we have seen the advantages, let's identify the products that Infineon provides for replacing relays and fuses. There are multiple ways of replacing relays and fuses in power distribution applications of an electrical and electronic architecture. Let's have a look at the most common ones. Dedicated functions, mostly up to 20 amperes of nominal current, move to the body control module. Dedicated functions move to an electronic control unit, ECU. And the electrification of a relay and fuse box to an electrical power distribution center. Another interesting way is to move dedicated functions or complete domains to a highly available energy board net using a power net protection module or box with ASIL B or C integrity. All this would be too extensive to cover in full, so we will focus our attention on the first three. Let's begin with the most popular one, where dedicated functions, mostly up to 20 amperes of nominal current, move to the body control module. Replacing relays and fuses in the body control module is in itself nothing new. Here we can find a complete infrastructure of supply, control, and communication to add more and more functions, such as the ones coming from the relay and fuse box. For more information, please have a look at Infineon's body control module application pages. A more challenging replacement of relays and fuses occurs in the so-called under-the-hood environment. This includes the move of functions to ECUs located in the engine compartment, where we have higher ambient temperatures than in the cabin. Similarly to the body control module, the ECU offers a complete supply, control, and communication infrastructure to add functions. To include these functions into an under-the-hood ECU, Infineon offers the Profit Plus 2 12-volt Grade 0 product family, which is designed and qualified according to AEC-Q 100 Grade 0 with a maximum junction temperature range up to 175 degrees Celsius instead of the classic Grade 1 maximum 150 degrees Celsius. This new high-side switch family is an excellent addition to the wide range of Grade 0 products, such as various Oryx microcontrollers, supply ICs, such as OptiReg Linear TLT8X, and communication ICs, such as CAN transceiver TLT9X. The most effective way of replacing relays and fuses is the electrification of the relay and fuse box to an electrical power distribution center. It transfers the classical hardwired plug-in relay and fuse box into a printed circuit board with surface-mounted components, including a supply, control, and communication infrastructure devices. At first sight, it seems that such a transformation has a higher cost compared to a pure relay and fuse solution. However, there is a higher saving potential at the system level. Let's take a look at some examples. The location of the relay and fuse box in the car is restricted to easily accessible areas to limit labor cost in case of malfunction. Because of the much higher reliability, diagnose capability, protection features, and much smaller size, the electrical power distribution center is an added value at system cost level and can be located anywhere. As a consequence of the flexible location in the car, such boxes can get distributed into a decentralized power distribution system where complexity, weight, and cost of the wire harness can get significantly reduced. The considerably reduced power losses enable less energy consumption, which means less fuel and, consequently, less CO2, which can have a very high value. An early feasibility study from Daimler with a Tier 1 and Infineon on these three types of relay and fuse replacements identified an overall system cost saving potential of up to €18 per car. Besides the cost savings, increasing the power dependability is another motivation to replace fuses with semiconductors. For safety reasons, especially for upcoming higher-level automated driving functions, the human misuse of a fuse replacement, that is, using the wrong fuse, may result in a violation of the Energy Board net specification, which may lead to an unintended failure coupling to operating functions such as steering. For more information, visit our power distribution webpage. In this last section, let's dive deeper into the solutions that Infineon offers for electrical power distribution centers. For relay and fuse replacement, Infineon offers a highly scalable portfolio of high-side switches grouped into three major product benchmark families. Power Profit is Infineon's smart high-side switch family for nominal currents up to 40 amperes. This family is designed to drive high currents, where high energy capability and challenging current profiles are required. Profit Plus 2 is the newest family of smart high-side switches for nominal currents up to 32 amperes. This family provides outstanding energy efficiency with reduced current consumption, state-of-the-art current sense accuracy, benchmark low cranking voltage capability, and EMC optimized for faster switching. Spock Plus 2 is the newest family of multi-channel serial peripheral interface high-side power controllers for nominal currents up to 15 amperes. The family offers 4 and 6 channel devices, and the SPI enables the configuration of channel parallelization, restart strategy, slew rate, protection, and diagnosis. For more details, have a look at the product family pages. Let's now take a closer look at each family. The Power Profit family is designed for the replacement of relays and fuses with semiconductors of high current and high energy capability. The most prominent devices in this family are the following. BTS 50010-1TAD is the benchmark for lowest ohmic smart switch on the market with a nominal current capability of 40 amperes. BTS 50015-1TAD is the benchmark for energy capability of 550 millijoules at 33 amperes. BTS 50025-1TEA with an on resistance of 2.5 milliohms comes in a D-pack package. It is the best compromise between small footprint, low on resistance, and high energy, as well as high thermal capability. For more details, have a look at the product family pages. The Profit Plus 2 12-volt family with grade 0 according to AEC Q100 offers an extended junction temperature range up to 175 degrees Celsius for under-the-hood power distribution applications. This family offers a unique feature set. Family approach that enables high design flexibility between grade 0 and grade 1 families. Partitioning at high ambient temperatures with higher ohmic parts due to extended thermal budget of grade 0 devices. Diagnosis tailored to address power distribution applications with precise current sense accuracy at nominal and high currents to distinguish between the nominal current and the fault current. For more details, have a look at the product family pages. The 1ESP branch of the Profit Plus 2 family is the newest smart high-side switch family extension. It comes in a TS-DS024 package for nominal currents up to 32 amperes. Its pin-to-pin footprint and functions are compatible with the existing Profit Plus 2 family in TS-DS014 package. However, the most prominent feature of this new family is the capacitive load switching mode, implemented to charge capacitive loads and to reduce current peaks during the switch-on of high capacitances. You can find more details, download data sheets, and get information on evaluation boards on the product pages. For switching load currents beyond 40 amperes of nominal current, which cannot be handled by single devices, Infineon offers the discrete combination of gate drivers and MOSFETs. Let's first have a look at the MOSFET family. Infineon offers a wide range of 40-volt N-channel automotive qualified power MOSFETs using Optimos 5 and the new Optimos 6. This MOSFET technology is used in the most advanced and innovative packages in order to reach the best product performance and quality. Newly released product highlights are in TOL-G HSOG8 and the new power package S-TOL HSOF5. For more details, have a look at the product family pages. AUIR324X devices are high-side MOSFET drivers for back-to-back topology. The devices are automotive qualified according to AEC Q100 and feature a very low quiescent current both in on and off state. In the Power Distribution Center, the main applications in focus for the gate driver and MOSFET are Q-diode or ideal diode in start or stop systems, battery switch, and high current relay replacement. Both AUIR3241S and AUIR3242S are a combination of a boost DC-DC converter using an external inductor with a gate driver. Further common features are wide operating voltage of 3 to 36 volts due to boost converter, low quiescent current in on-state less than 50 microamperes, support to standard MOSFETs with gate output voltage of 12.5 volts, support to back-to-back configuration applications, gate undervoltage protection or lockout, loss of ground protection, and analog gate current monitoring. The only difference is the input level for turning on the MOSFET without power consumption. For AUIR3241S, the input is high active, and for AUIR3242S, the input is low active. For the AUIR324X family, Infineon offers demo boards in back-to-back configuration for 12-volt applications. An example of where it can be used is in the replacement of bistable relays in fail-safe applications, where fast switching is requested. Such configuration enables currents up to 50 amperes of continuous current at 25 degrees Celsius and 80 amperes for 1 minute. You can find more information in the user guide in our demo board page. For the supply and communication of the Electrical Power Distribution Center, Infineon offers a wide portfolio of application-optimized product families from discrete to highly integrated solutions. OptiReg Linear is Infineon's family of linear voltage regulators. It's an easy-to-use power supply solution that generates stable output voltages for all automotive applications. Infineon completes the supply family with the OptiReg switcher products. To integrate supply with communication, Infineon's OptiReg System Basis Chip (SBC) family is the best choice. For more information, visit the corresponding product pages. Infineon's OptiReg SBCs combine voltage supplies, such as LDOs or DC-DC converters, with low quiescent current modes with communication interfaces, such as CAN-FD, CAN partial networking, and LIN transceivers. These devices also integrate a wake-up functionality, as well as supervision fail-safe functions, such as fail-safe outputs, watchdog, and fail-safe operating modes. Travio 2 CYT2B7 series is based on a single ARM Cortex-M4 FPU and is a perfect match for electronic power distribution centers. It comes with 1 MB flash and interface capability up to 6 channels in CAN-FD and up to 8 channels in SCB and LIN-UART. Check out the product webpage and discover the Travio 2 community, code examples, knowledge base articles, among other information, tips, and best practices. Infineon products have various go-to-market support materials to guide you and equip you with the right collaterals and videos for a speedy design-in and time to market. Visit our website to learn more, and don't forget to log into My Infineon to unlock more content. Before we end, let's recap some of the things we have seen. The in-vehicle power distribution is the controlled transportation of energy from a source to every load in a vehicle. Dependable power is forcing the replacement of relays and fuses with semiconductors. One of the most effective ways for replacing relays and fuses is the introduction of an electrical power distribution center. An electrical power distribution center includes semiconductors for actuation, supply, and communication. Infineon's power switch ICs offer a highly scalable portfolio to replace relays and fuses. Infineon's discrete solutions of MOSFETs and gate drivers enable relay and fuse replacement for currents beyond 40 amperes, and the board can be supplied with OptiReg linear or switcher devices. OptiReg SBC integrates power supply and communication. Finally, the Travio 2 microcontroller family covers the entire range of electrical power distribution center applications. Get ahead of the game by letting the information come to you with Infineon's newsletter for engineers. Click here and sign up today. You have now finished this training about Infineon's offering for automotive electrical power distribution. If you need further information about this topic, please use the following contact. Thank you for joining.